In this video, we are going to discuss about the module 2 addressing modes of computer organization and architecture. What actually the addressing mode is? The term addressing mode refers to the way in which the operand of an instruction is specified. The addressing mode specifies a rule for interpreting or modifying the address field of the instruction before the operand is going to be actually executed. So let us discuss about the particular module. The topic we are going to discuss in this video is nothing but implementation of variables and constants, indirection and pointer, indexing and arrays. Let's see before entering into the syllabus. Generating a memory address. How to specify the address of a branch target? Is there any way that can we give the memory operand address directly in a single add instruction into the loop? Yes. Using a register to hold the address of a number, then incrementing by 4 on each pass through the loop, we can do the addressing directly. So let's have a small example. Here we are going to have an example over here. Just I am going to take an instruction move n comma r1, and n is nothing but number, and r1 I am going to use a register over there, and I am going to have the count in the register r1. Then I am going to use a counter to know that one, to know how the number has been progressed over there. I'm going to have a counter R0, register has been created to count the numbers and determining the address, and next I'm going to do the process by adding 4 to the R0. Each and every instruction after it's going to be get executed, I'm going to decrement the counter. Then I'm going to check for the loop whether it's going to be 0 or not. Until it's 0, it's going to be entering into the loop and it's going to progress over there. When it's going to be satisfies the condition, then it's going to jump from the particular loop and it's going to store the data into the register R0. Such a way we are going to address the branch instructions. Let's see in detail about the module addressing modes. What actually the addressing mode is? As I already said, that the different way in which the location of an operand is specified in instructions are referred to as addressing modes. The addressing modes are going to be classified as 5 types basically. First one, immediate addressing, register addressing, direct addressing, indirect addressing, index addressing. So we will see this addressing modes in detail. Addressing mode. So before entering into this addressing mode, just we have to understood what actually an instruction is. Instruction consisting of 2 things. One is nothing but opcode and operand. Opcode is nothing but the operational code, and operand is nothing but the data which is going to be get progressed over there. And these addressing modes are going to be implied with an accumulator ACC and top of the stack. These two are going to be present over here. Okay, let's see about the first one, immediate addressing mode. Immediate addressing mode. What actually the immediate addressing mode is? The immediate addressing mode, the operand is given explicitly in the instruction. Explicitly in the instruction. If you're going to see that one, the use of a constant in the particular instruction is going to be called as immediate. Move r1 comma 5. 5 is nothing but the content which have been specified over there. The content is going to be moved directly into the register r1. Moving the content or the data into the register, that is going to be called as immediate. Then register. Register means specifying a data into a particular register, and we are going to do the operation wherever it's going to be needed. So such a thing is going to be called as register. So let us see about register indirect. The figure indicates that the register that holds the number of a register that holds the operand over here. Okay, so move r1 comma, within the bracket we are going to give r2, that is nothing but r2 is nothing but the register of a content where it's going to be get located. So example, if you're going to see that one, so r1 is requesting r1 data which is going to be present indirectly in the R2. R2 is consisting of 3, nothing but the register 3. Then from that data, it's going to be moved into the register R1. This is register indirect. And we're going to have two more instructions called as auto increment and auto decrement that we will see later as additional instructions. Coming to the direct address, use the given address to access a memory location. So directly taking the data from the memory, that is going to be called as direct addressing. Indirect addressing, indicating the memory location that holds the address of the memory location that holds the data. Example, AR. So AR is nothing but 101, that is going to specify some address. That address consisting of some other address as 104. So the 104 is nothing but the register where the actual data is going to be get present over. That is going to be outputted as a data which is required by the user. That's the way which we are going to identify this data is going to be called as indirect addressing. Then coming to the additional things, relative address. The relative address which is going to be the effective address which is going to be equal to the sum of program counter plus relative address. The program counter which specifies a data 2 and the relative address which specifies a data 100. So the relative data which is going to be sum of this two, where the data which is going to be get present over there. So it's going to take the sum of the program counter value plus the relative address value, and it's going to enter into that particular address location, and the data which is going to be stored in that location is going to be taken as an output of this. Such a way we are going to make that it's a relative address. So the relative address could be a positive or negative. Next we are seeing indexed addressing. In the index addressing, the expected address which is equal to the index address plus relative address. So here we are going to see about that the index address is going to have some value and the relative address is going to be have some value. So it's going to be the sum of both, and which is going to be taken as an address. From that address we are going to specify the data. Okay, this data is going to be outputted as a outcome of this particular addressing mode. So here this indexed addressing may be a positive or negative, which is going to be represented in a 2's complement, and which will be useful with auto increment or auto decrement also, that we will see in the additional instructions for the next slide. So coming to the next one, base register. The base register is a type of addressing which has a base register plus relative address. The combination of both is going to be there. Usually the base register point of always it's going to be the beginning of an array. So it's going to take the sum of relative address along with the base address, which is going to be taken. That address which deals with data, that is going to be outcome of this particular instruction. So here the relative address data may be a positive or negative, which also represent in a 2's complement. So these are the types of registering addressing modes which have been come across over there in this particular module. So we have come across with immediate register addressing mode, absolute or direct addressing mode, indirect addressing mode, index addressing, base with index and offset, relative addressing mode, and two more instructions are going to be there, auto increment and auto decrement, that we will see in the next slide. The different ways in which the location of an operand is specified in instructions are referred as a addressing mode. So we are going to, this diagram shows that how the assembler syntax and addressing and functions have been assigned to a particular thing that has been shown over there. So immediate means it's have an assembler in syntax is going to have its asterisk value, and it's going to have its operand, a value will be present over there. And coming to a register, which consisting of a register value, the expected address is going to be an RI value. Absolute consisting of a location, a memory location. So actually the expected address is going to be a memory location. In the indirect, always we are going to see about that indirectly the location is going to be stored in a specific register that's going to be shown over there. And index addressing which is nothing but combination of the relative address with the indexed addressing. Base with index, combination of relative address with the base register. And relative address is nothing but a combination of program counter with the relative address. And auto increment and auto decrement is nothing but a single instruction which is going to increment as well as the decrement the particular content which is going to be present in the particular instruction. So let's move on to the next topic called as implementation of variables and constants. What actually the implementation of variables and constants? A variable is represented by allocating a memory location to hold its value. Thus, the value can be changed as needed using an appropriate instruction. There are two assessing modes to assess the variables. Okay, let us see about that. First one is nothing but register mode. The operand is the content of a processor register. Second one, absolute mode. The operand is in mandatory location. It's nothing but memory location.